This is Balkishan, lecturer in chemistry, Government Degree College, Siddipet, Telangana. Today, our topic, reduction reactions of carbonyl compounds. Reduction reactions of carbonyl compounds. Reduction reactions of carbonyl compounds. In this one, number 1, catalytic reduction. Catalytic reduction. Catalytic reduction means by using of catalyst like platinum, palladium, nickel with hydrogen, that reduction takes place. It is called as catalytic reduction. Carbonyl compound general is the C double bond O. This is the carbonyl compound. Carbonyl compound on reduction with hydrogen in the presence of nickel or platinum or palladium. Nickel or platinum or palladium, it converts into the CHOH. Converts into the CHOH. That is here what happens, the double bond O with HH this hydrogen added to this carbon and this one added to this one. Okay, now CH and OH, this is called alcohol. This is called alcohol. Okay, that's why carbonyl compound on reduction with hydrogen in the presence of nickel or platinum or palladium to form alcohol. Okay, and about this reaction, it is a free radical reaction. Free radical mechanism. It is a free radical mechanism. Next one, in this reaction if aldehydes aldehyde, if aldehyde used then obtain primary alcohols. Primary alcohols. Here aldehyde means for this one 1R and 1H plus hydrogen with nickel or platinum or palladium. Now this R and H, one more H and OH. This is simply write as RCH2OH. RCH2OH. Tarvata, if ketone is used then secondary alcohols are obtained. Secondary alcohol is obtained. Okay, here this is the aldehyde this one is ketone. Hydrogen in the presence of nickel or platinum or palladium. We obtain R, and R already present, 2 R's. One hydrogen is added to this position and one hydrogen added to oxygen. This can be written as R, R, H, O, H. So this is the primary alcohol. This one is the secondary alcohol. This one. Okay. Catalytic reduction. Carbonyl compound reduces into alcohol in the presence of hydrogen. The catalyst is nickel or platinum or palladium. In this reaction, the reaction mechanism or reaction takes place with periodical mechanism. And if aldehydes used in this reaction, we obtain primary alcohols. If we use ketones, this is the ketone, we obtain secondary alcohol. For example, example 1, I am taking acetaldehyde, CH3CHO plus hydrogen in the presence of nickel or platinum or palladium. Okay, this is this one, CH3 and H, hydrogen HCH. This hydrogen added to carbon, one more hydrogen added to oxygen. Then we obtain O, H, CH3, and already H is present. One more H is added here. This can simply written as CH3 and CH2OH. CH3, CH2OH. It is called ethyl alcohol. Ethyl alcohol. Acetaldehyde reduces into ethyl alcohol with hydrogen in the presence of nickel or platinum or palladium. When we take, instead of acetaldehyde, benzaldehyde, this is the benzaldehyde, hydrogen, same condition, we obtain benzyl alcohol. This is the benzyl alcohol. This is the benzaldehyde. Third one, when we take acetone with hydrogen, same catalyst, we obtain CH3 and CH2 CHOH, CH3. How it is obtained? Hydrogen added to this position and one hydrogen added to this position, double bond converted to the single bond. It is called as isopropyl alcohol. Isopropyl alcohol. This is the acetone. Acetone converts into the isopropyl alcohol. This is the secondary alcohol. This is the primary alcohol. That's why aldehydes, you take benzaldehyde is also primary alcohol. This benzyl alcohol is also primary. Aldehydes will give the primary alcohols. Ketones will give the secondary alcohol. One important information about this reaction. When we take this is CH3, CH double bond CHO అండి. This is called crotonaldehyde అండి. Crotonaldehyde అండి. When it is subjected to hydrogen, subjected to reaction with hydrogen in the presence of nickel or platinum or palladium, what happens అండి, this aldehydic functional group converts into the alcoholic functional group. Already we see so many reactions అండి. At the same time అండి, this double bond also we have, this is very very important అండి. Nickel or platinum or palladium by hydrogen అండి can convert అండి C double bond group into the C single bond group. Okay, and also C triple bond group also converts into the single bond. And one more అండి, C double bond O group converts into the CHOH group. The action of hydrogen in the presence of nickel or platinum or palladium అండి, it can reduce the double bonded carbons, triple bonded carbons and carbonyl group. This is very very important information. And the nature of this hydrogen with catalyst అండి, it can reduces carbonyl group and also in advance అండి it can reduce ester also అండి. It can reduce carboxylic group also and COOH group also. Carboxylic acid group also reduces, and that's why hydrogen is the strongest reducing agent. Here in this case I am showing this one. Here this CHO group converts into the CHOH. Okay, and this double bond also converts into the single bond by the adding of hydrogen, 2 moles hydrogen in this one, 1 mole added at this position and remaining mole, second mole is added to at this position. Then CH3 already present, CH already present, 1 hydrogen is added to this one, it becomes a CH2. Here already CH is present, double bond converted into single bond, CH and H and it becomes as CH2 and CH2OH. CH2OH. This is the N-butyl alcohol. N-butyl alcohol. This based on this one only, in some case only, convert, here one exercise, convert acetaldehyde into N-butyl alcohol. This is one conversion. Convert acetaldehyde and CH3CHO into N-butyl alcohol. In this reaction we have 2 reactions. One is 2 moles of acetaldehyde in the presence of dilute NaOH and heat this is called aldol condensation. Aldol condensation. We obtain this one, crotonaldehyde. Okay, this crotonaldehyde when subjected with nickel hydrogen subjected to reduction, we obtain this N-butyl alcohol. This is one of the conversion by taking off 2 carbons containing is converting into the 4 carbons containing alcohol. This is the some advantage of this reaction. First one, catalytic reduction completed. Catalytic reduction, that is with hydrogen, catalyst is maybe nickel maybe platinum or maybe palladium. In this one, aldehydes converts into the primary alcohols, ketones convert into the secondary alcohol. In this reaction, C double bond C also reduces, C triple bond C also reduces into the C single bond carbon. Okay. Now second one, reduction with lithium aluminum hydride or sodium borohydride. Reduction with lithium aluminum hydride or sodium borohydride. Okay. Now carbonyl compound reduces into the two hydrogens it will be supplied by lithium aluminum hydride or sodium borohydride. It converts into the alcohol. This is the carbonyl compound. Carbonyl compound. This one is the alcohol. That's why carbonyl compound reduces into alcohol in the presence of lithium aluminum hydride or sodium borohydride. It is similar to the catalytic reduction, but small change will take in this case. And mechanism of this reaction, lithium aluminum hydride is supply will supply this lithium plus Al H3, and I am showing H separate I am this one at minus. Okay. Now this carbonyl group here, that is Li plus Al H3, one H I am showing separately approaches the carbonyl group. Approaches the carbonyl group and it shifted towards the oxygen. Oxygen gets negative charge partially. It is negative charge, it is positive charge. The positively charged, this hydrogen shifted to this side and obtained this is already double bond HO by shifting up this one here minus. Okay, remaining part is Al H3 Li plus. Al H3 Li plus, the hydrogen bonded to this one in the form of H minus. This one it is shifted to this side this hydrogen shifted bonded electron shifted to this side, H minus. Here carbon plus plus minus will neutralize here minus and here plus, it can be neutralized. The overall charge is here 0 minus plus overall charge will be 0. Now after this one 3 more, here 3 hydrogens are present here one hydrogen is converted C double bond O into the CHO minus and 3 moles of C double bond O groups are this hydrogens, 3 hydrogens added to this one and this one shifted to this side already 1 here present the total this is CH here 3 here 1 and here O minus, totally 4 Al Li plus Al Li plus this one. Finally this will converts into the, by taking off any other in the presence of acid or any we are mixing the total this 4 hydrogens added to this one, it becomes as a CHOH CHOH and plus Al take 3Cl minus becomes as a AlCl3, and Li take 1Cl becomes as a LiCl. 3 plus 1 4 and 4Cl, 4H added to this one and it becomes as alcohol. This is the simple mechanism how the lithium aluminum hydride, and similarly only instead of lithium here sodium, instead of aluminum here boron, and same mechanism can be visualized with sodium borohydride also. Okay, you replace sodium, that is lithium, by sodium and aluminum by boron. These two are the same, and according to diagonal relation and the properties of aluminum nearly equal to the properties of boron. And okay, now this is the mechanism and in this case only, when we take only aldehyde in this reaction, here R, here H only, we obtain this one. This is called RCH2OH. This is called primary alcohol. That's fine. When lithium aluminum hydride or sodium borohydride and reduction with that is aldehydes only, we obtain primary alcohol. When we take instead of aldehyde ketone only, this reduces into the secondary alcohol. So this is the secondary alcohol. Therefore, you remember only aldehyde will give primary alcohols and ketones will give secondary alcohols, and in this reaction. Okay, one important thing only, this lithium aluminum hydride or sodium borohydride, these two will not reduce only C double bond C groups only. Okay, that's why I am showing this one. When we take this crotonaldehyde only, this crotonaldehyde, when we with nickel hydrogen only, with lithium aluminum hydride only, with sodium borohydride. Sodium borohydride. What happens only, this nickel hydrogen can reduces with two groups only. One is the CHO group, other one is the C double bonds. That's why it becomes as a CH2, CH2OH. Just before reaction, this one only. Then butyl alcohol is obtained. But in the presence of lithium aluminum hydride only, this will not reduces. This only crotyl alcohol is obtained. Crotonyl alcohol is obtained. Crotonaldehyde, that is crotonyl alcohol. Here also same. That's why you remember only, in the presence of lithium aluminum hydride or sodium borohydride, there is no action at double bonded carbons. Okay, this is the very important only. When we take only, you remember, here instead of methyl group or alkyl group, when we take phenyl group only, this highly reactive or electron withdrawing group, if present in the benzene ring only, in the presence of lithium aluminum hydride or sodium borohydride, there is a choice to reduce the double bond into the single bond only. Okay, this is reduction with lithium aluminum hydride and sodium borohydride. Third one, Meerwein, Condorf, Verli reduction. MPV under reduction. Mervyn Pandar-Felly reduction. This one is statement and the conversion of only ketone. Conversion of ketone into secondary alcohol. Secondary alcohol in the presence of isopropyl alcohol and this one aluminium isopropoxide. This is the statement. Conversion of ketone into secondary alcohol. Conversion of ketone into secondary alcohol in the presence of isopropyl alcohol and aluminium isopropoxide. What is that reaction? So this is the ketone. This is the ketone plus this is the isopropyl alcohol. This is the ketone. This is the isopropyl alcohol. This is the double arrow. Forward is the reduction, backward is the oxidation. The forward reaction is known as MPV reduction. The backward reaction is called as open air oxidation. Already I given at the time of preparation of carbonyl compounds. Okay, or properties of alcohols, that one. Anyway, again you remember the forward reaction. That means ketone reduces into the secondary alcohol in the presence of aluminum isopropoxide, isopropyl alcohol is called as Mervyn Pandar-Felly reaction. The back one is the oxidation of secondary alcohol into the ketone in the presence of aluminum isopropoxide is called as open air oxidation. Open air oxidation. Anyway, this is only exchange only. This CH3 will attend here and R will be added at this position. This one or R, that is, this is called as secondary alcohol. Plus byproduct is this one. Acetone is the byproduct. Acetone is the byproduct. Okay, that's why again statement, ketone reduces into secondary alcohol in the presence of isopropyl alcohol and aluminum isopropoxide. And this is the formula, Al OCH and CH3 again CH3 taken thrice, aluminum isopropoxide. This one AlCl3 laga. This Cl is chloride. When Cl is replaced by isopropoxide, 1, 2, 3 oxy, isopropoxy group and propoxide, AlOCH CH3 CH3. It is called as aluminum isopropoxide. Okay, I am explaining this mechanism also clearly. Mervyn Pandar-Felly reduction is the reversible reaction. Forward reaction is the reduction, backward reaction is the oxidation. Forward reaction is called as Mervyn Pandar-Felly reduction. Backward reaction is called as open air oxidation. In this reaction, ketone reduces into the secondary alcohol. Backward reaction, secondary alcohol oxidizes into the ketone. Okay, now mechanism of this reaction. Here this is the ketone. Ketone. First it reacts with this one, Al, O, CH, CH3, CH3 taken. I am writing only twice only. One is I am separating only. O, C, H only, and CH3, CH3. Now this bond is ready to shifting towards the oxygen only. It gets negative charge, and this bond also ready to shift in between this one only. This bond also ready to shift this side only. At that stage, a new bond will form with this carbon. Okay, at this stage only, a transition state is obtained. This is the R only. Here C, R. There is no effect at this one only. Now this carbon is ready to bonded with hydrogen. So this is the hydrogen. Here double bonded oxygen only is converting into the single bond. Just I am showing with dotted line only. That bond is ready to cleave. That's why I am showing with the dotted line only. Now is aluminum is also ready to bond with that oxygen only. I am showing that with dotted line. Remaining O, CH, CH3, CH3 taken twice is same. And here this bond is ready to cleave. Bond. Okay na? Ready to cleave. And this one. Here carbon contains this bond also ready to make double bond. This bond is shifting this side, means already single bond is present. Now it is changing into the double bonded carbon. Already here hydrogen is present. That hydrogen is ready to cleave. That's why I am showing with dotted line. Remaining CH3 and CH3. There is no change. Okay, because this is called as transition state. This is very important one. In this ketone only, carbon to oxygen, there is a pi bond. This pi bond is ready to cleave. At that time, oxygen gets negative charge, carbon gets positive charge. The positively charged carbon attracts the air due to the shifting of this hydrogen, this bond towards the hydrogen. Hydrogen is getting negative charge. This negatively charged hydrogen is ready to bond the positively charged carbon. That's why there is a new bond between carbon to hydrogen. And here hydrogen in between carbon, the bond is ready to cleave. So this is the cleave, dotted line. This is the new bond formation, dotted line. Here also only, this is the sigma bond. There is no choice for the cleavage. So it is the pi bond is ready to cleave. That's why I am showing dotted line. Here oxygen to aluminum. Here ready to form a new bond between the oxygen and aluminum. That's why I am showing a dotted line. Okay, totally remaining part is same. But this is transition state. Finally only converts into the this total bond shifted to this side. There is no bond here. Here, so this bond totally shifted to this side and there is no bond. Here this bond also totally shifted. That means only what happens only this is eliminated. CH3 and C double bond O CH3 called as acetone. Acetone will be eliminated. And R already present. There is a single bond. Here new with hydrogen. Here O and Al, O, CH, CH3 and CH3, okay, taken twice. After this one and now isopropyl alcohol will enter. This is the isopropyl alcohol. Already I given the what is the statement and ketone reduces into the secondary alcohol in the presence of aluminium isopropoxide. This is the aluminium isopropoxide. Aluminium isopropoxide. Aluminium isopropoxide and secondary, that is isopropyl alcohol. This is the isopropyl in the presence of aluminium isopropoxide and isopropyl alcohol. This isopropyl alcohol, this one shifted to this side and hydrogen will give this one. Now bond is shifted to this side. O minus, here Al. Due to the shifting of the sigma bond towards the oxygen, Al becomes plus charge. The plus charged oxygen bonded with aluminium. This plus charged aluminium bonded with oxygen. And the final product is R already present. This CH and already are present. O already present. Now O is added with hydrogen. So this is called as secondary alcohol. Plus byproduct and aluminium O CH CH CH3 and already taken twice and here also CH3 CH3 CHO and added to this one, means already 2 present, one more is added, means 3. Initially here we added and finally it is removed and that's why it is only catalyst. Aluminium isopropoxide here only catalyst and reducing is the isopropyl alcohol. That's why ketone reduces into secondary alcohol and isopropyl alcohol in this reaction oxidizes into the acetone. This is very, very important. Secondary alcohol obtained from the ketone. We are taking the reducing agent is the isopropyl alcohol in the presence of aluminium isopropoxide. This is the reducing agent and aluminium isopropoxide and isopropyl alcohol is the reducing agent. In the presence of these two, the ketone is reduces into the secondary alcohol. Okay, so this is about the Mervin-Pondorf-Verley reduction. It is very important and after this one more reduction, Clemmensen reduction. Clemmensen reduction. Clemmensen reduction. Clemmensen reduction is also the carbonyl component. Carbonyl compound reduces into, this is CH2. This is called alkane. Alkane in the presence of zinc amalgam and HCl. Zinc amalgam, the alloy of any mercury alloys are known as amalgams. Here zinc is present, that's why zinc amalgam HCl reduces carbonyl compound into the alkane. When we take here like CH3 and here one hydrogen, this is called CH3CH1 called as acetaldehyde. Acetaldehyde. In the presence of this one zinc amalgam and HCl, this will be the total and oxygen eliminated as a water molecule. Eliminated as a water molecule. Obtained and already CH3 is present. C will take 2 hydrogens and becomes as a CH3. And here one oxygen will take 2 hydrogens, eliminated as a H2O. As a H2O, it is called as ethane. Ethane, and this is alkane. You take one more CH3 and CH3 and C double bond. It is called as acetone. Acetone. In the presence of zinc amalgam and HCl minus H2O will give CH3 already present. This part becomes as a CH2 only, near CH3. Okay, that's why it is called as propane. Propane is a alkane. That's why here this one R CH2 is a alkane. Alkane. That's why carbonyl compound reduces into alkane in the presence of zinc amalgam and HCl is called as Clemmensen reaction. It is also important reaction. Clemmensen reaction. In this Clemmensen reaction, the conversion of carbonyl compound into the alkane. What is the mechanism involved in this one? Is only to increase the activity of zinc and here mercury is supplied. That's why here what happens C double bond O group with H plus ion obtained from HCl. I am showing like this one. This bond shifted to this side, donated to this one, and obtained double bond O H, it is donated plus side. Now at this stage zinc it contains a lone pair of electron. That's why this shifted to this side bond shifted to this side. At the stage already bond is present. Here single bond, here OH, here zinc donated electron means positive charge. If zinc is donated electron pair, that's why it gets positive charge. This positively charged Zn plus, so this is very important this zinc will give only 2 electrons. This is the important. This becomes as a plus 2. This plus 2 only will combine with 2 Cl minus already here is present. Okay. At that stage so this will become. So this is the important step in this one. Already OH is present. Here Zn minus is present. This eliminate in the presence of Zn and H 2Cl minus. These 2 electrons transferred to Zn plus. 1 electron it becomes as a neutral. 1 more electron becomes as a minus. After this one at the same time here 2Cl means 1 H plus also required this H plus ion is added to this one. Here it also present a lone pair of electron, takes it becomes as a plus. With a deuterion here plus charge, here minus charge. At this stage so this minus shifted to this side, water molecule is eliminated. This is the minus H2O. There is a double bond between zinc and carbon. Zinc and carbon. At this stage here 2 molecules of HCl 2 molecules of HCl. This will be take 2 Cl and eliminated as a ZnCl2 and 2 hydrogens added to this one. This is nothing but CH2. This is the alkane. This is the Clemmensen reduction. Okay, that is Clemmensen reduction. Carbonyl compound converts into the alkane. Same similar reaction. Just I am changing. This is the last reduction reaction. Same, it is similar to Clemmensen reduction. Just changes the catalyst. Wolff-Kishner reduction. Wolff-Kishner reduction. Wolff-Kishner reduction is this one. Carbonyl compound reduces into alkane and this is the alkane. When we take zinc amalgam and HCl is the Clemmensen reduction. Instead of zinc amalgam HCl, I am taking hydrazine H2N NH2. This is called hydrazine. And hydrolysis with B.S.C. So this zinc amalgam replaced by hydrazine, HCl replaced by KOH, Clemmensen reduction changes into the Wolff-Kishner reduction. But what is the mechanism? Here step 1 is formation of hydrazone. Formation of hydrazone means the double bonded carbonyl group reacts with H2 and H2 only. Now this will be eliminated as a water molecule to form. So this is called as hydrazone. This is step 1. Step 2, formation of alkane. The hydrazone and this is the hydrazone with base and here OH minus is present. I am showing this one as a separately and this H plus OH minus eliminated as a water molecule and now here double bond already present N and one more NH and here due to the shifting of this bond towards the nitrogen gets negative charge. This negative charge shifted to this side and bond shifted to this side. At that stage now water will give H plus ion. Already we added a OH minus here OH minus is eliminated. This H plus ion, this is H plus ion only, bond shifted towards the OH, it becomes as OH minus and H plus added to this carbon. At that stage C already present, a single bond, nitrogen to double bond, here H and here one hydrogen is added. Now next OH minus will take this one. At that stage H already present, here single bond, double bond N, here minus. Here H plus OH minus eliminated as a water. Next one in the presence of water, this bond shifted to this side and it becomes this side. Now added OH minus is eliminated, H plus and added to this one. The final one is already H is present, new H here, nitrogen to this one. Double bond N means nitrogen is eliminated and OH minus is eliminated. So this is the outcome. So this is the Wolff-Kishner reduction. Clemmensen reduction, Wolff-Kishner reduction, both are same and just only reagent or catalyst will be changed. Zinc amalgam and HCl is the Clemmensen reduction, and hydrazine KOH is the Wolff-Kishner reduction. In this today class and reduction reactions, when we take in the presence of hydrogen with nickel or platinum or palladium, lithium aluminium hydride or sodium borohydride, and one more is the MPV and Mervyn Pond of Verley reduction. This will give the alcohols. Okay, the last two, this Wolff-Kishner reduction and Clemmensen reduction will give the alkanes. Okay, thank you. Today class over.